App Engine services. Google App Engine provides a range of services including caching via Memcache, external services via URLFetch, asynchronous communication via XMPP, email, image processing, Cron, jobs, task queues. Caching via Memcache. Memcache is an in-memory key value store for small chunks of arbitrary data, that is, strings and objects, from results of database calls, API calls, or page rendering. It allows you to retrieve your most commonly accessed data from cache, ideally from in-memory. Memcache service and asynchronous Memcache service are used for access the Memcache service object. The method put used for store the key value pair, and the method get will be used for get the value stored in memory. The put if untouched and get identifiable methods of the Memcache service can be used to handle multiple requests. When we need to use Memcache to speed up common data store queries, session data, user preferences, which are usually most of the web pages, temporary values which are not used for persistence. Then when it expires, values may be affected when new values added on low cache memory. Values are affected due to memory pressure. That least recently used values are affected first. You can specify the time in seconds for the value at creation time or via admin API. See how to create an example. For that, we will create a servlet called Memcache test, add two entries to the data store as well as in the Memcache, and then modify the web.xml to configure the servlet. Let's try to create an example. Go to Eclipse, create a new web project called GAE services with default package services, and then click on the finish. It created a project. Now let's open this or create a new class called GAE or Memcache test. It should be a servlet. We'll extend these servlet properties to this class also. We have the doGet method. We'll write a similar doPost method. Which are the defaults for the any HTTP servlet. In the doGet method, we'll modify or we'll create two entities. Before creating entities, we will start with the transactions. For that, transactions options equal to transactions option dot builder dot write xg with true, and then we'll create a data store. Before we'll create here data store service data store equal to data source service factory dot get data source service. So it requires the saying that it's not converting asynchronous, so we'll try to get the synchronous. Data store service, and then we'll start our transaction equal to data store dot begin transaction. For this import this is not used, data store transaction will use, and then entity creation. Entity customer equal to new entity of customer by providing nickname as a key, and we will set some attributes to the customer. For example, name, as a Cron, age as a 40, and then we'll add these customer to the data store. That put entity customer Similarly, we'll create a new customer with nickname 1, that is customer 1, which is related to same customer but with ID as a different. Vikram, age 50 for the customer 1, and I will put the same thing, data store dot put and transaction dot commit. Whatever we have done is still we created 2 customers and we added them to the we added them to the database. Now before, if you want to perform transactions, we need to perform these transactions options to the transaction and then save this. Now we need how to cache these two customers. For that we will create a key cache from the Memcache service, that is Memcache service Memcache equal to Memcache service factory dot get Memcache service, and then we will retrieve those two keys for the customer 1 and customer in a key equal to customer dot get key this is for the customer, and similar way we'll get the keys for the customer 1 also. We have these two keys. Now we will put these two keys in the key cache, that is Memcache dot put object as a key and value as a customer, and second one also with the key 1 and customer 1. Now the customer and customer 1 are stored in memory by using the key and key 1. Now let's try to retrieve the data from the Memcache. For that we will use the key cache dot get key. Generally I am using within one example. You can use these outside or somewhere within your application. So I am trying to get entity E equal to Memcache dot get key. For this we'll add a cached to entity. This E has the customer related information. From that I'm going to get the name. For that just write in the response of our servlet customer name, that is E dot get property of name. Similar way we'll write entity E1 for the customer 1 object, and then I will say here customer 1 name equal to E1 dot get. Now let's try to run this by modifying the web.xml. Which means we'll write a servlet mapping for that particular service. I'll use cache test as a URL pattern. For that memcache as a servlet name, and the same servlet will be mapped to the our exact servlet class called Memcache test. Now let's start the server. Go to any browser by taking the URL, and generally it points to the main index.html. Instead of that, I'm using this cache test as a URL which directly calls this servlet, and it will store these two entities in the data store as well as in the memory cache, and get and printed those two values from the memory cache. See, we got the name as a Kiran and Vikram. Let's see how these two values are stored in the data store. See, we have only one customer, but two rows we were here with Kiran and Vikram. These two values we retrieved from the cache. If we have like this huge object, we can use them frequently by using the Memcache. We tested this application successfully. URLFetch. To communicate with other applications or access other resources on the web, Google App Engine uses the URLFetch by fetching the URLs of any of other resources with help of HTTP and HTTPS. In generally, a simple way to get the context of page at URL is to create the java.net.url object, then call its OpenStream method. This method handles the details of creating the connection, issuing an HTTP GET request, and requesting the response data. App Engine implements this interface using the URLFetch service. Your application doesn't make socket connections directly by using the App Engine. That's why App Engine provided the URLFetch service. You can set a time for request to wait for response by using the URLFetch service. The URLFetch service supports both synchronous requests and asynchronous requests. With a synchronous request, the API call to fetch a URL and wait until the remote host returns a result, then returns control to application. An asynchronous request, it requests to the URLFetch service, start the request, then returns immediately with an object. In Google App Engine Java, the asynchronous interface is available with URLFetch service.fetch asynchronous and providing the request. The HTTPS protocol methods are used to connect the secured servers. The fetch can be either by get, post, put, head, delete methods of HTTP protocol. The URLFetch service returns all response data including the response code, header, and your application can connect to systems behind your company's firewall using the Google Secure Data Connector. Example. In this example, we'll create a simple URLFetch test servlet and create a sample text file and then access that file in our application and modify that code to read the text file, change the web.xml to access the servlet, and test this application on Google App Engine server. For this, go to Eclipse and create a new servlet called URLFetch test For this, we'll extend the doGet as well as doPost, and in the doGet method I'll write the URLFetch service to get the URL, and I'll write the response after getting the service. For this, first we need URLFetch service, that is fetcher equal to URLFetch service factory dot get URLFetch service dot get URL. It returns the fetch. For that, we'll create an URL of java.net.url. This is the URL where we need to mention our. This URL can be either your files located in your App Engine server or outside the world. For example, we can retrieve the google.com or files which are located in Google, includes Google Docs or some other files, or some files which will be stored in some other servers. So right now we are trying with some sample file by creating text file test.txt, which contains URL test on Google App Engine. We'll try to display this information, and for this we'll provide the URL. This URL, this application we are going to test on our Google App Engine server, so I'll provide in a short moment with our application ID followed by the test.txt. After that, we will create a response for the fetcher.fetch, and then we'll provide our URL, which directly communicate with the URL provided here, and then it returns the response. From this response, we will write our response code and context to the servlet output. For this, response.get writer of this HTTP servlet response I am writing here. Get writer dot print, I will say response code of this response dot get response code. It will show whether success or bad request or failed or something. Similar way, I'll print the context. So I need to provide the URL. For that, I'll use the same innobudge GAE1, and I'll modify my appengine.web.xml with the required application ID. Now appspot.com, this is our previous application where I'm storing my test.txt. Right now it's not available, but we'll upload that file to this Google App Engine. So I'm using the same URL over here, and upload your project to Google App Engine. Now if I retrieve the data txt.html text, it should be available in the appspot.com domain. So we need to test this, that's why we need to modify our web.xml file to get this URLFetch test servlet. For that, I'm writing a servlet mapping saying that URLFetch, for that saying URLFetch test. This is my servlet. We need to re-upload this project or redeploy this project to Google App Engine. So once you are successfully updated, let's take this URL pattern and go back to your previous page, and I am directly accessing our servlet. This is the response code success 200, and this is the actual value, but we can directly see the content of this by modifying the servlet over here, content, and then we can get the data available in the txt file. Asynchronous communication via XMPP. The XMPP stands Extensible Messaging and Presence Protocol. App Engine support XMPP compatible chat messaging services such as Google Doc. An app can send and receive chat messages, send chat invites, request a user's chat presence and status, and provide a chat status. The incoming XMPP messages are handled by request handlers, which are similar to web requests, and also supports chat notifications and chat interfaces to services, but group chat is not possible over here. An app can send chat messages to any XMPP address by calling the XMPP service API. Now we have different categories over here: sending the chat messages, sending the subscription, and receiving the messages. In this, we will see how to send a chat message. We'll create a new JID object by providing some mail ID with message body, and we'll construct one message object by providing our JID and message body, and then we will send a message to the new created JID through XMPP service.send message. This is the sending message in any normal XMPP service. Now we'll see how to handle the incoming call, that is incoming messages. App Engine provides 3 inbound services to manage the messages, subscriptions, and presence. Previously we discussed how to send the messages. This is how to receive the messages, how to subscribe, and how to check the presence. For this you need to enable 3 inbound services in the App Engine web.xml. Those are XMPP message, XMPP presence, and XMPP subscribe. The XMPP error is used to receive any error stanza, and the XMPP message which used to receive the chat messages. Whenever you define XMPP presence, it says whether your chat person is available or unavailable, and this subscribe used to subscribe between the user and the application. We'll see one by one in detail. Handling the chat messages. With the XMPP message service enabled in the App Engine web.xml, an App Engine makes a HTTP post request to the following URL path whenever you receive a chat message. That URL is /ah/xmpp/message/chat. This is default. You cannot configure this one. This is provided by the App Engine. To handle the incoming messages, you simply create a request handler that accepts post requests at this URL path, and then we will receive the request in the XMPP service factory.getXMPP service, and then get the XMPP from the JID which came from the request. The post request data represents from, to, body and other stanza. An application can receive messages of two XMPP types, that is chart and normal. Other will be rejected. Handling the chart messages and the web.xml modifications. In the web.xml, here if you observe here, for the URL pattern message chart, we define our XMPP receiver. In this XMPP receiver servlet, we will write our code to give response back whenever someone send a chart message to us. We will see the example in coming session. Subscription. By XMPP subscribe service enabled, Google App Engine allows your applications to receive updates to users' subscription information via posts to the following URLs. When there is a post to the XMPP subscription subscribe, it signals that the user wishes to subscribe to the application's presence. Post to the XMPP subscription subscribed signal that the user has allowed the application to receive its presence. Any post to XMPP subscription unsubscribe signals that the user is unsubscribing from the application's presence. And any post to XMPP subscription unsubscribed signals that the user has denied the application's subscription request or cancelled the previously generated subscription. How to check the user presence? By enabling the XMPP presence inbound service allows your application to detect changes to user's chart presence. Any post to XMPP presence available signals that user is available and provides the user's chart status. In the same way, the unavailability can be checked. Any post to XMPP presence / unavailable, it signals that user is unavailable. Post to any XMPP presence probe request a user current presence, that is whether he is busy or in a call, in a meeting. Such situations we can check over there. An application can send and receive messages using several kind of addresses or JIDs. One kind of addresses used the application ID and appspot.com domain. For example, if you want to send an invitation, you can send that your application ID at the rate of appspot.com. Now, by enabling the XMPP error inbound service, it allows your application to receive XMPP related error stanzas. For the subscription, user presence and error stanza changes, web.xml for the respective URLs and the equivalent handlers to handle the request. For subscription, user presence and an error stanza, we need to do the changes to the web.xml for the respective URLs and the equivalent handlers to handle all the requests. Example, in this we will create some sample chart invite JSP which sends one email ID for asking to chart invitation. For that, we need a chart invitation servlet which actually does the sending the invitation, and we need to have message receiver servlet.java which needs to respond whenever someone sends a message to us. and configuring the app-engine.web.xml for inbound services. Modify the web.xml for the servlets and test on the app server. Here I have the chart invitation JSP. Which has one table with input type text accepting the email ID and one submit button. This, once we click on this submit button, it will says that it goes to the send chart invitation servlet. Here what we will do is we will read our chart ID, that is our email, and we will send an invitation. For this we created one XMPP service from the XMPP service factory.get XMPP service, and then by sending the invitation with new JID of invitee, that is the email ID whatever we entered in the input screen. This is written in a special method called send invite. This method is called from the do post of the send chart invite servlet.java. Similar way, we have the message receiver servlet. What it will do, whenever there is a message presence is available, it comes to this message receiver method, and it tries to read the message from the request, and then it will get the user ID from where it came, and it forms the new body message. Will say then just saying that we will offer 10% discount. It's not a direct online face-to-face chat, but we configured here to send some response back to them. For this we build a message with our from ID, that is from where we got the request, and then we are sending the response back to that by saying that XMPP send present with our status message. For these two servlets, we modified the web.xml see here, one is send the chart invite servlet, another one is message receiver servlet. Whenever you click on the JSP chart invitation, it will come to the URL pattern send invite. Whenever there is a chart presence, that is someone replied to our chart invitation, then all the messages come to the message receiver servlet. As we explained, to do this we need to enable the application.web.xml properties by mentioning here. For that we need to say inbound services XMPP presence and XMPP subscribe and error stanza for that XMPP error. We enabled all these for XMPP message presence and subscriber error stanza. So all our application is ready. Right now what I am going to do is I am going to upload this to the app ID InnoBudge GAU1. Right click, Google, deploy to App Engine. Let's go to the URL and invite someone for the chart. I'm going to send invitation for inno.budge 2012 @gmail.com. Before sending invitation, let's see the user has any invitations from the innobudgae1@appspot.com, because if we send an invitation for discussion, it will send through innobudgae1@appspot.com. Let's go to the other page. Check here in the chat invitation, no other invitations found. Then from the other browser, I'm sending for discussion to innobudge2012@gmail.com. Let's here. Now I got one invitation saying that innobudge1@appspot.com. Let's say yes, and right now this application is available. If I any message from here, now as we explained previously, the app engine receives all the incoming SMS at this URL path, that is _ah XMPP message/chart. If any message came here, it calls this message receive servlet, and here in this message receive servlet, do get and do post method, we are calling only one method, that is message receive. And then from here we are just sending a small body saying that we will offer a 10% discount. Just send a some sample here saying that hello. By default it will say that we will offer a 10% discount. That's it. This is the default message we'll get from there. So now let's go to the logs of this application. In the logs, see, we subscribed successfully, and then the availability came here, and then we got the chart also from here. We given the reply properly to the income chart also. This is what is called the asynchronous communication over the XMPP. Email. App Engine applications can send email messages on behalf of apps administrator or on behalf of user with Google accounts. To send an email, we need to create Java mail session. For this, you do not need to provide any SMTP server configuration. App Engine will always use the mail service for sending messages. For this, we'll just create a properties file and session, some string for message body, and this is the message format from this session, and we will add the from address, that is to address, that is add recipient, and the subject and message body which we created earlier, and by using the transport.send we will send this mail to a particular to address. How to receive an email? Apps can receive email at various addresses mentioned at the rate of your application id.appspotmail.com. The test means you can include any string over here. To receive email, you first configure inbound services at appengine-web.xml. That is the service name as mail. Create mappings from the URL path that represent email address to handle your app's code. That is, you need to have a handler related to the URL pattern for any incoming mail. The URL path _ah/mail followed by incoming email address used that pattern /* matches the all incoming email addresses. In your application, create the servlet class to handle the incoming mail requests. An outgoing email messages can have 0 or more file attachments. A header has name and a value with in reply to, list ID, list unsubscribe on behalf of parameters. The Java development server doesn't send the email messages. Only the app engine after deployment, you can send a mail. App engine uses the DKIM protocol to authenticate the sender's domain. Let's try to create a sample with JSP to send a mail to specific email ID and equivalent servlet class to send a mail from the mail sender Java class. Define a mail receiver servlet Java class which will receive the mails if is sent from any Google authenticated mail IDs, and modify the web.xml for the servlet configurations and add the inbound services to the app engine web.xml. Then deploy your application. Let's see how to create a sample. In the send email.jsp, I have created one input text box to store the email ID and one submit box which will send an action to send email action to the web.xml. In the web.xml, the send email has the servlet mapping with send mail servlet. It simply read the email address from our JSP and passes this to another class called send mail send method. This reads the to address and some subject from the previously we configured, saying that send test mail from Google App Engine with the body got the Google App Engine test mail. And then it will create the properties file, sessions and messages by setting the from address and to address, subject, body, and then by using the transport.send method, it sends the email from address to address. We have deployed this application successfully. Now let's go and test it. This is our Hello App Engine and we have created JSP. That JSP name is send email.jsp. Here I'll give one email ID to send a mail saying that innobudge to 2012@gmail.com, and go to the actual email and check whether you have the emails already in this or not. We don't have any emails. Now just by clicking the send button, it's saying that mail sent successfully to this Gmail ID. Let's see whether we got a mail or not over here. See, we got the mail from the innobudge GAE which we configured already in our Java code. So we can use any Google mail ID or authenticated mail ID over here to send mail to any other users. With body saying that we got the GAE test mail. Image processing. App Engine provides the ability to manipulate image data using the dedicated images service. The images service can resize, rotate, flip and crop images. It can composite multiple images into a single image, and it can convert the image data between several formats. It can also enhance photographs using a predefined algorithm. The app API can also provide information about an image such as format, width, height and a histogram of color values. The images service can accept image data directly from the application, or it can use a blob store value or Google Cloud Storage values, which means we can directly access the images from the application, or we can store in somewhere and we can access those images. It does transformations to the images using a service instead of performing image processing on the application server. The app prepares an image object with the image data to transform, and the transform object with instructions on how to transform the image. The app gets an image service object, then call it apply transform method with the image and the transform objects. The service accepts the image data in the JPEG, PNG, GIF, BMP, TIF and other ICO formats from the blob storage. Example: in this we'll create some sample file upload that stores the image into the blob, and we will read the image from the blob and we'll do the transformations on the image. For that, let's go to the Eclipse, and I already have the file upload.jsp which have the one form action to the upload. It will read the image from this input type text box and it will upload into the blob. For that, we are using the blob store service API, blob service, and then we are passing the same action to the upload. Here the upload action mapped to the upload servlet, it just reads the blob storage and puts into the blob of our app, Google App Engine, and then it will redirect to serve method. It will read that image from the blob, and in the resize it will do the again by reading the blob key and making the old image. By using the image service, we will transform this old image by making less size, by making the resize of 20 to 30, and we will create a new image and we will display this image on the servlet. To do that, right click, run as web application project, take the URL and relaunch this one by saying file upload.jsp. Choose any file from these and submit it. It will retransform and it will give a small size image. See, the size of image gone very less. Cron or scheduled jobs. Cron jobs allows you to configure regularly scheduled tasks that operate at defined times or regular intervals. These cron jobs are automatically triggered by App Engine cron service. You might use this to send out a report email on daily basis, to update some cache data for every 10 minutes, or to update some summary information once an hour. A cron job will be invoke a URL using an HTTP GET request at a given time of day. For this, a cron.xml file in the webinf directory of our application controls all the crons for your Java applications. This is the sample cron.xml, which has the 3 different cron jobs. One is recharge, runs for every 2 minutes, and one is weekly report, which runs on every Monday at 8:30 for America, New York Standard Time Zone. Another one, it will run on every Monday 8:30 for America, New York Time Zone, but of your application version 2. A cron.xml file consists of number of jobs defined as shown previously. A job definition must have a URL and a schedule. You can also optionally specify description, time zone and target. The description is visible in the admin console of your App Engine. The URL field is just a web URL in your application. The schedule is the time format settings. that should be like every 12 hours or every 5 minutes from 10 o'clock to 2 o'clock, or 2nd of 3rd of Monday, Wednesday, Thursday for every March 17 hours. The time zone should be name of standard time zone format. The target specifies the version of your application. You can also run in regular intervals. Let's see the example by creating cron.xml to send a mail to every 1 minute. For that, we will define one URL. That URL will be handled by cron job test servlet.java. Modify the web.xml to handle the servlet. So let's go to the example and deploy this to the application and test it. Let's see. We have the cron.xml by specifying the cron job to send a mail to every 1 minute. Here this is our schedule every 1 minute. You can send may specify 2, 3 or hours or minutes. That formats depends on you. For this send cron, we defined our web.xml configuration with this servlet, cron job servlet. This, whenever you 1 minute reaches, it comes to the doGet method and it sends a mail from innobudge to a mail to innobudge2012@gmail from the innobudge GAE. This is a sample class having the send method to send a mail. This will read the mail properties and send the mail directly to from and to addresses. Right now we are going to send a mail to inno.budge2012@gmail.com. Let's remove already existing cron jobs and upload your application to Google App Engine, because we cannot test this in the development server. Initially, it will show that there is no cron jobs over here. Once your application deploys successfully, deployment completed, then you can able to see the cron jobs in your app environment. Right now it's saying that there is a one cron job to send a cron for defined for every 1 minute UTC. It's saying that it hasn't been run till now. We'll check for a minute. By that time we are able to get the email. If you see here, right now there is no email as we shown previously, and we are waiting for 1 minute to send an email. You can see the logs. Once if you send a mail, these logs will be available over here. Let's see our cron job has been run or not. It's showing that on time success, means job has been executed successfully by sending the email. Let's go to this and we got the cron is running. So we define our cron for every 1 minute to run. It's not good to keep this cron job keep running in the production, so I'm disabling this cron job. By just commenting this cron job and update your deploy this application to Google App Engine, then automatically your cron job will be disabled. Task queues. It's a powerful tool for background processing. They allow your application to define tasks and add them to a queue, and then use this queue to process them in aggregate manner. A task is a unit of work to be performed by the application. The app inserts these tasks into one or more queues based on the queues configurations. App Engine provides two different queue configurations. One is push and another one is pull. Push queues process the tasks based on the processing rate configured in the queue definition. These are the default one and function only within App Engine environment. Whereas pull queues allows an alternate task consumer to process the task at specific time, either inside or outside of the App Engine. But your application needs to scale workers based on processing volume, as well as it needs to delete the task after processing. App Engine provides a default push queue to all applications, but there is no default pull queue. App Engine provides default queue. You can use this immediately without any configuration. All versions of the application share the same task queue. Queues needs to be configured in the queue.xml under webinf directory. The push queues are used to enqueue a task. Then you get a queue using the queue factory. By using the queue factory, call the add method that will be added to the queue. You can get a named queue specified in the queue.xml file using the getQueue method of the factory, or you can get the default queue using the getDefaultQueue method. This is a sample queue which we need to configure in the queue.xml. Here the order passing queue is the queue name, and these are the other parameters. Based on these parameters, the queue will be executed. This is the getting the queue for define order passing queue. For that queue, we are adding one task saying the process order. It simply sends in a mail in our example. This task has been added to the queue by using the queue.add task options. App Engine executes push tasks by calling options specific URLs with the request handlers for those tasks. These URLs must be local to your application root directory and specified as a relative URL. Here the process order is our relative URL in our local machine. The order in which tasks are executed depend on FIFO, that is first in first out, and backlog tasks in the queue, milliseconds and countdown milliseconds properties. Pull queues. It allows a task consumer to process tasks outside of App Engine's default task processing system. The task consumer releases these tasks either via the task queue API or task queue REST API. The task queue API used if the consumer is internal to the App Engine. The task queue REST API used if the consumer is external to the App Engine. The consumer processes the tasks if the task fails to execute before the lease expires. The consumer can lease it again. Once task executes successfully, the task consumer must delete it. That is the property of pull queue. App Engine sends task data to consumer directly. Define a pull queue in queue.xml. We need to define all our queues which required in the queue.xml similar to push queues. An example. We'll define a queue.xml and we'll create a send to queue servlet.java which takes the queue name and add that queue with a task. We will create one more servlet, queue process test servlet.java, to run the queued tasks. Test this on the App Engine. Let's go to Java Eclipse environment. see the queue.xml. Here I created one order processing queue test with some other default parameter configurations, and this order processing test will be used in the order servlet. Whenever you execute the order servlet, it first read the order processing queue test. This is the queue defined in the queue.xml, and it will add the task to this queue. The task is process the order. Okay, once you deploy this application in your App Engine configuration, you can see the queues available. I already updated this one, that's why it's showing that already order processing queue test is available. If you don't have, it will say that there is no queues defined in the application. But for the order processing queue task, we don't have any jobs are in the queue. It will show which are the jobs in the queue here. So once the order process job, when you try to run from here from the admin console by clicking the run button, once you have the jobs, it will enable the run button. By clicking the run button, it will go to the process order URL. The process order URL consumes the process order, and it simply send a confirmation mail. Let's try to put one queue. For that, just your app / will take the send it to queue. I'm invoking directly. Once this executed successfully, then it's saying that order processing queue added successfully to the queue. Let's see how many queues are there in progress. So we'll go to this. We have the two queues to process the order. We'll click on the run process right now, and then one job is processing. This means it just send a simple mail to our saying that InnoBudge confirmation of the order on queue process. That's the end of the Google App Engine. Thank you.